Hello guys and welcome to another video. Right guys, today's video it will be differentiation part 3. So we are going to be looking at tangents of lines to curves and also perpendicular to lines. Okay, so we will be going through like one example that's actually detailed, okay, in this example. Right guys, okay, so this is going to be aimed at further maths GCSE actually, A-level maths and also some like university students that are studying first year maths for example. Right guys, so differentiation actually, so we looked at in our last lesson, differentiation is all about being able to find gradients, okay, at any particular point. So the derivative dy by dx is used to find the gradient at any point, because if you remember from before actually, we said that the gradient here obviously it will be different to the gradient here, because the gradient here will be negative, the gradient here will be positive, and there's actually no gradient actually at the point 0 0. Okay, for obviously that's for like quadratics, cubics, and like so if it's just a graph where it's y equals x to the power of something, okay, 0 0 will always obviously not actually always give a gradient of 0 actually in that situation. Okay, right guys, okay, so we are going to look at tangents to line to graphs. Okay, because differentiation is so the summary of this is that we are looking at gradients or at given points. Okay, so example one actually, equations of tangents and perpendicular. Okay, so y is equal to x squared. So part A says find dy by dx. Dy by dx is equal to 2x. Okay, so 2x. So remember that the power comes down by 1. Okay, so remember that y equals x to the n. Dy by dx is nx to the n minus 1. Okay, so if you're not sure, obviously check out my previous video on that. Right guys, okay, so 2x over. So that tells us the gradient at any given point. So for any chosen value of x, that will tell me how to actually work out my my value for x, okay, at that point. Right. Part B, find the gradient at x equals 4. So we're going to sub in x equals 4 into dy by dx, okay? 2x means 2 times x, 2 times 4 is going to be 8. So the gradient at x equals 4 is 8. Okay? So that's my gradient. Right, part C. Find the equation of the tangent at x equals 4. Okay, so first of all, we have to work out our y coordinates. So we sub x equals 4 back into the original function. Okay, y is equal to x squared, f of x is equal to x squared. So y is equal to 4 squared. 4 squared is going to be 16, which is there. So my coordinates are there. And then now, guys, I sub in. Okay, so remember, equation of tangent actually. So it's always a straight line actually. So it always follows y is equal to mx plus c. So a tangent, guys, a tangent just means that it's a line that touches the curve or circle or whatever at a particular point. So the tangent of the curve at x equals 4 is a straight line that touches the curve or circle at that point. Okay, so that's how I would do that actually, for that one. Okay, so I've got my coordinates, so I sub it into here. So y1 is my y coordinate, x1 is my x coordinate. So what x1 is equal to 4, y1 is equal to 16. Okay, so y minus 16 is equal to 8 brackets x minus 4. Expand my single bracket on the right hand side. Y minus 16 is equal to 8x minus 32. I'm going to add 16 to both sides because I want it in the form y equals mx plus c. Okay, so it's usually in the exam actually it will want it in the form y is equal to mx plus c. Okay, where m is your gradient and c is your y-intercept. So the gradient here is 8 and it crosses at minus 16. So it would look here, so if I extend actually, it would look something like that. So it would be like a straight line that is in that shape. Okay, so that's how I work out the gradient of my tangent at a given point. Okay. Right, guys, last part actually of this. Okay, find the equation of the perpendicular to the line, Okay, at x equals 4. Okay, so perpendicular here means that it is at right angles to the line. Okay, so right angles means that that is actually 90 degrees actually. So this line here, then my perpendicular will look something like that. Okay, so a little rule, guys. Okay, if it's perpendicular, actually, it's always the negative reciprocal. What that means is it's minus 1 over that number. So the gradient here is going to be 8. The perpendicular gradient, actually, it will be negative 1 over 8. So it's minus 1 over that number. Obviously, if it's a fraction, then all you do is just flip, actually. So obviously, if you're not sure, check out my video that I made on reciprocals, actually. I think it was actually last week. Reciprocals, yeah, just means like 1 over that number. So it's so the perpendicular gradient, actually, guys, yeah, it's a little rule, actually. So it's always perpendicular gradient is always my negative reciprocal. So y minus y1 is equal to m brackets x minus x1. Y minus 16 is equal to minus an eighth brackets x minus 4. Okay, expand this, minus 1/8 times 4, it will give me positive 4 over 8, actually, which simplifies to a half. Minus 1/8 times x is minus 1/8 x. Okay, add 16 to both sides. Y is equal to minus 1 over 8 x plus 16 over 2. Okay, or y is equal to minus an eighth x plus 33 over 2. Okay, so either one of those guys, it will give you the right answer. Okay. Right, guys. Okay. Yeah. I hope that made sense, guys. Actually, yeah. So that was a video, yeah, on like lines, actually, yeah, and perpendicular, actually. Okay. If you want to practice some questions, guys, yeah, obviously, check out, yeah, TL Maths, actually. So like Jack Brown, actually, there are actually loads of works, actually, yeah, on that website, TL Maths. Also check out Primo's Kitten, okay, and then Corbett Maths, okay, for that. Or if you just type in, actually, like differentiation worksheets, yeah, then it will actually come up, actually, on actually Google, yeah. So the differentiation worksheet PDF. Okay, there'll be some questions, and I will try and like leave like a link in the description, actually, yeah, for any more like websites that I come across. Okay, thank you for watching, guys. Actually, yeah, I hope that actually made sense for like today's lesson. Okay, yeah. Thank you for watching, and I'll speak to you soon. Bye now.